Hello and welcome. In this video, we're going to be sketching a function, and for the first time on the channel, we're going to attempt to sketch a polynomial function. What I've been doing so far was rational functions. Today, we're going to sketch something a little bit different. So let's start with the main function. So the function goes like f of x equals minus x to the power of 4 plus x cubed plus 2x squared. So from here, let's walk through our steps, the 6 main steps to sketch any function. Let's start by the first one, finding the domain of the function. Again, domain is our values of x where my y is going to be defined, or basically where horizontally my graph is going to be. Is there any restrictions do I have on any value of x? Over here, x can be anything. X can be 0, can be 1, can be -2, can be minus infinity, minus 1 million, 1 trillion, whatever. It will always give us a y value. However, we always have restrictions when we have something like this. Let's say 1 over x plus 1. Here we will have a restriction because we know anything over 0 is going to be undefined, so I cannot have my denominator as 0. So the number that will make the denominator 0 is -1. So my domain for this function, for example, y equals this, is going to be all real numbers except -1. However, over here in this example, for a polynomial, the domain is going to be, is all real numbers. And just take it from here that for any polynomial, the domain is always going to be all real numbers. Step 2 says, locate the x and y intercept. Okay, let's start with the y intercept. So if we want the y intercept, or where the graph touches the y axis or intersects the y axis, we set the x equal to 0 and we find the y. So over here, my f of 0 is going to equal -0 power 4 plus 0 cubed plus 2 times 0 squared. So basically this is 0, 0, 0. So my y is also going to be 0. So this is going to be my y-intercept. It occurs at x0 and y equals 0. For the x-intercept, we do the exact same thing. However, we set y equal to 0. So if y equal to 0, I will have -x power 4 plus x cubed plus 2x squared equals 0. And let me multiply everything by -1. So this becomes plus, this becomes a minus, and this becomes a minus. So to solve this, let me try and factorize. So over here straight away, I can see that I can take an x squared out common. So let's do that. So let me take x squared. I'll be left with x power 4 divide x squared is x squared, minus x cubed divide x squared is x, minus 2x squared divide x squared is basically 2. And this is going to equal 0. So let me continue factorizing what's inside. So I can see that this is a quadratic. I can do factorizing. And by the way, I did a whole series on quadratics. Please go check it on the top right hand corner. 2 values of 2 that subtract to 1 because this is minus. I know that it's 2 and 1. So I'll do my 2 brackets. Let's type the x squared first. I'll have 2 brackets, x and x. I'll have a 2 and I'll have a 1. And then since this is minus, the greater factor of this and that will take whatever the middle sign is. So the 2 is greater, middle sign is minus, so the 2 takes the minus and the other one takes the plus, and this is equal to 0. So from here, I have 3 options to have my function equal to 0. Either x squared equals 0, which makes x equals 0. That is the first value. So let's type it over here, x equals 0. Or I can have x minus 2 equals 0, which makes x equal 2 as a solution. X plus 1 equals 0, which is going to give me x equals minus 1. So these are the 3 x-intercepts that I have over here. So now we finished the x and y intercepts step. Let's check what is going to be the next step. So for step 3 and 4, a vertical asymptote holds, or horizontal asymptotes or oblique asymptotes, they do not occur in polynomial functions. These are only in rational functions. So 3 and 4, I'm going to skip those two steps. I'll just go to 5 straight away. I need to find the first derivative, find all the critical points, and I need to know where is the function increasing or decreasing. So for the fifth step, f dash of x is, so if we take a look at the original function, let's copy it so it's with us. Okay. So if we take a look at the original function, if I want to differentiate that, that's going to give me negative 4x to the third power plus 3x squared plus 2x squared. Okay, to find the critical points or the stationary points or the turning points or the points of maximum and minimum, this and that point, I will need to equate my first derivative to 0. So I'm going to have negative 4x cubed plus 3x squared plus 2x squared. This should be 2x, not 2x squared. This should be 2x. I should equate it to 0. So over here, again, I can see straight away that I can take a negative x out. Let's say I'll take negative x, and then I'll be left with negative 4x cubed divided negative x is positive 4x squared. 3x squared divided negative x is negative 3x. And then 2x divided negative x is minus 2 equals 0. Again, let's do a similar step. Let's try to find the solutions to this quadratic function over here. First, the first solution is going to be when I equate negative x to 0, giving me my first critical point at x equals 0. Then the solutions to this quadratic equaling 0 is going to give me my other critical points. So over here, I don't want to do factorization. What I can do is I can do quadratic formula. So the quadratic formula goes like this: minus b plus or minus square root of b squared minus 4ac all over 2a. So let's apply that over here. I can see that my b is negative 3, so minus b is going to be 3, plus or minus square root of b is negative 3, so negative 3 squared, minus 4 multiply. And by the way, this one over here, this is 2 times 2. This should be 4, and this should be 4, and this should be 4 as well. So minus 4 times a, so a is 4, and times c, c is negative 4, so minus 4 over here, and everything over 2 times a, my a is 4, so this is the quadratic formula. So one time you calculate it when it's plus, and another time you calculate it when it's minus, is going to give you two values. The first one being x equal 1.44. I'm going to round them into 2 decimal places. The second one is going to be negative 0.69, and these are my x coordinates where the critical or turning points are. So let me erase. I don't need this. Let's retype this. This is for x. Yeah, for x. Okay. So over here, I found my turning points. Let's I'm not gonna go through the increasing or decreasing part, because I can do that in the other step where it's the second derivative, getting the second derivative step. So step number 6 is to get f double dash of x. So differentiating this one more time, So differentiating the first derivative is going to give me minus 12x squared, because 3 times negative 4 is minus 12, minus 12x, and then reduce the power by 1. 3 minus 1 is going to be 2. And then for the second one is going to be plus 6x and then plus 4. So this is going to be my second derivative over here. Again, to find any critical or inflection points, I'm going to set the second derivative to 0 and find the solutions. Again, what I can do to solve this quadratic, I can use the quadratic formula, so it will go something like this. So minus b, so minus 6, plus or minus square root of b squared, so 6 squared, minus 4 times a, which is negative 12, times c, which is 4, and everything over 2 times negative 12. Again, I will use 1 time plus, 1 time minus. This is going to give me two answers. The first one being 0.87, and the other one is going to be negative 0.38. So these are the values of x which will make the second derivative 0. So these could be inflection points. Now, I know that these could be inflection points. I have the turning points. Let me use the second derivative test to test my turning points to know each one, is it a maximum or a minimum. So to do that, we just simply plug in the turning point that we want to test into our second derivative. If it gave me a positive value, then it's a minimum. If it gave me a negative value, then it's a maximum. So let's start with the first one, which is x equals 0. I can see that plugging x equals 0, this is going to be 0, 0, and it's going to give me plus 4. So it's a positive answer, making this turning point a minimum. Let's test the other one. So substituting 1.44 into the second derivative is going to be negative 12 into 1.44 squared plus 6 into 1.44 plus 4. I can see that doing this on the calculator, I'm not going to calculate it. I got it as a negative value. So this is going to give me a negative value. You can double check on your own. So if this is negative, it means that this turning point is going to be a maximum turning point. And let's do the same for the last turning point, which is negative 0.69. Negative 0.69. So over here, again, this is going to give me a negative value, meaning that this point is also a maximum. So now, let's use all this information in order to try and sketch our function. So first, what I like to do is I like to start with the x-intercepts. So I know that my x-intercepts occur at x equals 0 and 0. Let's say this is going to be 2, 4, 6, negative 2, negative 4, and so on. So our second x-intercept is at x equals 2. Actually, let's increase it a little bit. Let's say that 2, 3, 4. So this is 2, and then 1, 2, 3, 4. This is 4. So my second x-intercept is going to be over here, and negative 1 is going to be over here. Okay, so these are my x-intercepts. Right. Let's check my turning points, and let's actually get the y values of each turning point. How do I do that? By substituting the actual turning point into the original equation, which we can, I think it's copied. Yeah. So what we can do is we can test each turning point. Actually, we can plug in each turning point to get the corresponding y value. So when x is 0, I can see that plugging 0 here is going to give me a 0 value. So we have the point x0, and let's type it here, y equal 0. Let's actually put it here, y equals 0, x equals 0. For this one, putting negative 1.44 inside is going to give me, so negative 1.44 to the power of 4 plus 1.44 to the third power plus 2 times 1.44 squared. This is going to give me a y of 2.83, so y is going to equal 2.83 over here. And finally, placing negative 0.69, so minus negative 0.69 to the power of 4 plus negative 0.69 cubed plus 2 times negative 0.69 squared. This is going to give me y equals 0.40 in the y. So let's plot these turning points according to them being minimums or maximum. So the first one is at x0 and y0, and it's a minimum point, so I know it looks like this. So we're gonna have something like this at this part over here. Okay. Next is x equals 1.44. So if this is 1, it's around here, and y is 2.83. Let's say 2 is 1, 2, 3. So this is 2. So 2.8 is going to be somewhere, let's say somewhere around here. So 2 and 2.83 is going to be here. So this is my other turning point, and it's going to be a minimum. Okay, so it's going to look something like this. And then the final one is going to be at x equals negative 0.69. So it's around somewhere over here with a y of 0.4. So somewhere over here is my other turning point, and it's going to be something like this. Okay, so let me draw this a little better. So this is going to be like this. Yeah, this part is a minimum, this part is going to be maximum, so it's going to look something like this. So this is what I have over here. I know that my graph passes through, this is not 1.44, this is 1.44 is somewhere over here, and around 2.83, so it's over something over here. This is the second turning point, so it looks something like this. From here to here is like this. This is a minimum, so it looks something like this. Okay, and then I know that I will pass through my x-intercepts. I will pass through 2 over here. So it's gonna look like this. I'm gonna connect this part over here. This part I'm gonna connect, and I know that I had an inflection point around here. So let's check our inflection point. So it was 0.87. So around 1 or so. Yeah, 0.87 around here. This is an inflection point, and I can see that this is happening. The graph went from being concave up to concave down. This occurs at a inflection point, and then over here I can continue my graph to touch my x-axis. So my graph is going to look something similar to this. Obviously we can do a lot better if we choose a better scale and we have better, yeah, here we go. So the graph looks something like this. We drew all our turning points. Let me label them in green. So this is a turning point, this is another turning point, and that's the third one. We have an inflection point over here and an inflection point over here as well. So these two are inflection points. We have our x-intercept, 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 and then nothing else. We don't have any inflection points. So after this, the graph is gonna keep on going concave down forever, and here as well is going to continue. This is how you can draw a polynomial function. Please don't forget to like, subscribe, and comment down below. Feel free to ask any question if you want. Watch the previous videos, and thank you so much for watching.